كفاك دكتور بس أومان ذكرت مثلا ك أو ستيبي كتوخد فيري كودينج وبروجرامينج كدوالي كردي كبشكل بابرين ديتيلاني كندا تواندرا بهندك لبكارناني سوفت وير كان بارك ياخذ ببندريت تواني ببيني وميجري زور شدكيت انت قصتي في دواء أوم بيبلي
Staff outpatient. وديتي
بله
Yeah, do Jana. This is okay. So easiest way is for me to explain this. Cold rolled is when they get the material and they roll it. They put it through 2 rollers, condense it, compress it like this. So you can see cold roll. It's all very stretched. The crystals. And Rangaka, the colors correspond to if the atoms are arranged like this or like this or like that. Rankaboya. And it's not so for cold rolled you have alpha fiber, ohaya, gamma fiber, ohaya.
Okay.
No duana, alpha or gamma. After in 30 second steps of heating, you got to 90 seconds, you see alpha fiber, it hasn't recrystallized. You can see it still has orange color gradients within it, showing it still has a lot of, we could put it in dislocations to accommodate the orientation gradient. However, Timshai gamma fiber, okay, it's all new crystals. But most of them orientated the same way as gamma fiber.
Yeah. Are you using any image processing here, or is it everything like signal processing?
Using coding and a MATLAB toolbox called MTEX.
You know, but what I'm trying to say is here, how do you measure these sort of changes? Is it like through the signals, or is it all images?
The changes, so it's based on the diffraction patterns from electron backscatter diffraction. The diffraction patterns give you the orientation of the crystals it hits. So the way electron backscatter diffraction is it fires electrons at the surface.
And the reflection.
Yeah.
How it goes with it, how many
diffraction patterns, So within like a step size. So if it goes across the step size, fires electrons, you get diffraction patterns and so on.
Is it not possible to use image processing? Sorry, maybe it's a side question, but here the pattern is clear. But if
the diffraction patterns look like for example, Kikuchi bands. It's like it doesn't look like this. The diffraction patterns that come back are bands of like lines against the phosphor screen.
I see. But I'm assuming that there would be still some sort of texture changes in these sort of line kind of sort of checkerboard.
Yeah. So that's the orientation gradients. That's the color changes you can see.
I see.
That's the orientation gradients. Those texture changes along these crystals.
Perfect.
Based on the step size I used. So like these would correspond to dislocations, which would accommodate our orientation gradient. The dislocation density gives us an estimate of the amount of stored energy. Like it's not perfectly accurate. It's not something you can say this is exactly the amount of dislocation density we have, but it's an estimation, and it works quite well in our case.
Perfect.
Yeah.
So is it safe to say that this is the low level of some of the materials that we see, like outside when you see this something like this alloy wheels or these sort of structures are beautiful and shiny. You see this like very sort of soft and flat.
This is what it looks like up close.
But in the low level, we're measuring these sort of changes and controlling these sort of behaviors will eventually affect the heating, the efficiency of these sort of motors.
So like with heat, you can see the new crystal forms, and then the orientation of the crystal will then you'd be able to, for example, I had a different work in my thesis where based on formulas for magnetization, magnetic anisotropy, based on the orientation of crystal, I can give you an estimate of how much energy it would cost to magnetize that crystal along the plane. So looking at this, I can just apply that formula. I could say, so for example, these crystals on the left, where you might have an easier time magnetizing those along the plane, whereas crystals on the right, you need more energy. And then there's also, like, for example, things like crystal size. If you have small crystals, you have a lot of boundaries between crystals, which you'll have to magnetize across, and that will also cost you more energy. So you're balancing a lot of different things like crystal size, the elements you use. For example, if you put in atoms like carbon and things like that, which aren't magnetic, you have to spend more energy to magnetize material. The orientation of the crystal as well. If it's in a certain orientation like this, it's easy to magnetize. You go straight across. If it's like that, you have an extra atom in the middle, it's harder to magnetize. So it's all about energy, yeah.
That's what. So اگر بسیاری ئەوت لێ بکەم يعني حتا چەند ئەو کۆدینگ سکیڵی کە پەیدات کرد یارمەتی دەربوو بۆ ئەوەی يعني PhD-ەکەت ئاسانتر بی لە دوای ئەو ستێپەوە.
Zor, it made it so much easier being able to code all this stuff. Like it was saved me so like otherwise with the software I couldn't do this. I'd have to jump through hoops trying to figure out how to do this. Being able to code this means I could direct my analysis and align it with my research like goals. The things I'm really trying to question, I can just put it into my code and direct my analysis straight into it. And it makes it very easy to then transfer the data and the results to different things, which I can also show you. Let me get rid of that. I'll show you another image. So these are two different electrical steels. One has 3.2% silicon, the other one's only 2.4. So you can see again, you have the long crystal structures in A1 and B1 from after it's directly been rolled. As you heat it up every 30 seconds, you can see you have RX new recrystallized grains. You see how it changes. You can see how this one is much slower, this one is faster. And you can see the difference between the red and the blue or green in how long it takes to recrystallize. So and this is with code. When looking at the same area, I can link it back to its original state and calculate differences, percentage changes, gradient changes, and so on. Stored energy changes. Like I wouldn't be able to do that with software, or it would be very, very difficult doing it manually. For me, I had a script. I take the data from directly out of electron basket diffraction. I run my script on it through it automatically calculates everything I need and throw out.
That's
yeah. Whereas doing it manually, it would be days work. So doing this like myself, I learned a lot. It helped me ask the right questions of what I need to do. It gives you a greater understanding of both the material and the processes you need to calculate certain things. So like I gained a big understanding of dislocation density and certain things like that.
That's for stopping the winning.
Yeah.
I get this okay. This was كدكتور يعني it's fascinating براستي أو يعني fine details of the structures of the materials that we're using on our daily basis sometimes. And when someone like researchers like you working on a low level sort of it's amazing, and how these sort of energies and diffractions and so on and so forth is working.
No, it is. It's really cool, especially now that we have 3D printing from the atomic level up. It's all about making the perfect material for what you want to do.
Perfect. بافسر أقول لكم هيت machine learning كده بكار هنا ياخد IDAI و machine learning لكاتي دكتوراه كات even at a very end.
Like I experimented with it during my PhD, but because of time, I didn't go that much into it. I focused more on the coding analytics and stuff, publish my videos. And by the time it came to, I had to write up my thesis. I didn't have time to experiment further in machine learning, but it was something I was looking at because from papers I was reading, a lot of more people were going to machine learning. Well, at the moment, mainly to predict alloy properties. Like if instead of like spending money to create a material, alloying everything in a process that might cost thousands, you can predict it based on prior knowledge of how the different elements interact in other alloys or current alloys that have already been created.
زور ساكا اگر وزن بسیاری عملی نکردی سوپروایزر داخل مشرفی دکتوراه که چه بود سوانزی
دکتر سوران براسکا
او کرد بوا يعني
کرد بو خلقی سلیمانی
خلقی سلیمانی بو يعني صدفة شي
best supervisor I could have ever asked for.
او سوبرفايزر تاع سوشيال سوانزي يعني
نا اشتغلت في بورتسمouth.
Portsmouth University. زۆر تاکە
نعم.
ینی ئەکادمیکی کوردی ئەو هەشمان هەیە کە ئینسان ینی
Oh, کابراکی زۆر باش بوو. It was very important for him to push me and make me go to conferences, and he says you have to publish in good journals, you don't publish in this or that journal, you have to have a paper in ACTA. It was always driving me to learn more and better, and he was always introducing me to other academics and things like that to build my network.
زۆر چاکە زۆر چاکە نازم پێشەوە ئەگەر بچینە سەر بابەتی تر هیچ شتێکی کەمە دەربارەی دیکتۆرایەکەت حەز بکەی مەسەلەن باسی بکەی هیچ شتێکی تر کە لە بواری مەسەلەن دکتۆرایەکەت یاخۆ ئەو توێژینەوانی کە کردیتر لەو کاتەدا
First of all, I get طلبة if they're like thinking of doing a PhD, the most important thing is the ability to learn by yourself. You have to dive in and be passionate about the topic.
بزانم ئەوەیشی کە گرینگە دوای ئەوە سەبرت هەبی ینی هەموو شتێک فێر نابی لە مای 24 ساعت 2 ڕۆژ 3 ڕۆژ پێویستە سەبرت هەبی زۆر بخوونیەوە بە تێپەڕبوونی کات ینی ئەو سکیڵانە پەیدا دەکەیت.
You have to manage your time as well, and you can't learn everything through a PhD. Like you have to also, like for me it was very good in a research group. I can learn from other people as well. It speeds things up.
ئەگەر پرسیاری ئەوت لێ بکەم بەشداریکردن لە کۆنفرانسەکان تا چەند گرینگە بۆ تەلەبەی دکتۆرا بەشداریکردن لە کۆنفرانسە زانستیەکان؟
You mean how many conferences I went to?
And not how many conferences, like how important it is for a PhD student to attend conferences.
Sure. Because like there's a lot of, like for example, for me it was very important to go to conferences to see how the experts in my field publish their results, present it, and where the field is currently going, what people are doing, opportunities for collaboration. One of the people I met at the conferences ended up being my external examiner for my Viva. So it was good knowing him, so I was more comfortable when the questions came.
دکتۆر دیوین باسەوەی دەکات تەلەبەی دکتۆرا زۆر گرینگە بەشداری ئەو کۆنفرانسانە بکات لەبەرچی یەکەم شت دەبینی کە ئەوانەی خەبیرن لە بوارەکەی خۆتدا توێژینەوەکانیانت ئاگا لێ دەبی ئەوە یەک دوو دەزانی مەسەلەن نوێترین توێژینەوە و یاخود پرۆگرێسی ئەو فیڵدەی خۆت چییە سێ مەسەلەن ئەکادمیشی دیکە دەناسی مەسەلەن لە ڕووی ئەوەی دەکرێت لە داهاتوو مەسەلەن توێژینەوەی زانستیان لەگەر بکەی یاگە تۆ تەلەبەی دکتۆرای دەکرێت کە لەوانە مەسەلەن بتە ممتحنت مەسەلەن بتە external examinat کە باس دەکات دەرێک لەوانە من لەو کۆنفرانسانە دیتم external examiner بووە and I think it's a good venue to even publicize your research as well. People know who you are, what you're doing.
هەموو کۆدینگ وشتام کرد ئێستا کۆنفرەنس بەرادرشم هەبوو گوتی ئێستا ئەمن بەرادرم هەیە دکتۆرا و PhD هۆشتانە لە سینید over there. They wanted to do what I did with my code, so because of that I published a paper with them. They got in touch with me. I worked on this project with them, and it was on a different material even compared to mine, but it was the same theory I applied for calculating stored energy in my code. So because of that, it gave me an opportunity for collaboration. It was a pretty good Chinese university as well, Harbin Institute, which is blacklisted by America at the moment.
Why is it blacklisted, by the way?
Yeah, they're blacklisted because a lot of what they do is in defense and military.
I see. دەستخۆش کاکتۆر بابم تۆزێک باسی هەندێک خبرەکان و یاخود ویشانە بکەم کە لە دوای دکتۆراوە دەست پێکردیە هەر وەکو وەبیرهێنانەوەتیش کاکتۆر مەسەلەن لە زانکۆی نۆتینگهام بەکەلۆرسیفنت لە زانکۆی کوین ماری یونیڤرسیتی هەندەسێتە بابرێن ماستەری خوێند لە هەندەسەی تەیەران لە زانکۆی سوانزی دکتۆرای خوێند لەسەر ماتیریال ساینس و فۆکەسەکەش زیاتر دەربارەی ئەو پێکاتە کریستەڵانەی کە زیاتر لە بۆ مەچینەی کارەباییەکان بەکاردێت چاکە باسی مەچینەی کارەبایی دەکەین لە کوردستان ڕاستەخۆڵانەیە فکریان لە بۆ مەچینەی کارەبایی ماڵهەند لەوێەوە دەتوانی باس بکەی هەتاوەکو مەسەلەن سارەی کارەبایی هەموو ئەو شتانە و باسی ئەوەشمان کرد کە چەند گرینگە مەرج نییە تۆ ئیلان سۆفتوێر ئینجینێرینگ یاخود کۆمپیوتەر ساینس بیبرێ من کۆدینگ دەکەم لە بوارەکانی کەش ئەو نمونەیەکی ترە ئەگەرە تو کۆدینگ سکیلت باشبی یاخود کۆمپیوتەر پرۆگرامینگت باشبی دەکرێت لە بوارەکەی خۆت زۆر یارمەتی بدات بەڕاستی دەست خۆش کاکتۆر دەمێت دوای دیکتۆراکەت ئەگەر خبرەی خۆتم پێ برەی ئەگەر ئیشت کردبی لە دیتا ساینس یاخود لە مەشین لێرنینگ ئەگەر بچینە سەر و بابەتە تۆزێک
ئێستا هی Pish, wow, so like for example, I'd say I'll start with the job search. So I've just graduated, and during Corona, there weren't a lot of good jobs in engineering out there for me to be able to apply both my analytics and the coding, all the skills with my, because I still wanted to work in research. So the only options for me were as a postdoc or specialized like research engineer jobs, and there weren't that many there. So while I was looking for a job, I was just continuing to apply my coding skills and learning as much as I could, and learning new things. So I was trying to make as much use of my time, especially during Corona. You can't go outside. Might as well learn something.
Yes.
Yeah. So I did quite a few cool things during my job search, where I learned a few things which I think some of the students in Kyrgyzstan might be interested in. So the first thing I did was I helped some humanitarian researchers who were doing research on like the situation in Afrin, in Syria, on ISIS. Like one of them is a Kurdish guy who got his research published in the UN. So there I was using my Python skills just to do data visualization for him and geospatial visualization. Because of that work, an American researcher who now works in the State Department's Conflict and Stabilization Bureau in America, I ended up working with her, and I'm currently working with her on a paper using my coding skills and data visualization skills on the Turkish-Kurdish conflict. And prior to that, we published a paper at the Institute of Counterterror on the effect of Turkish airstrikes in Sinjar and Yazidis, where using my Python skills, I learned how to take in data from Twitter based on certain keywords, so relating to airstrikes in Turkish. So there's a lot of Turkish accounts that post every time there's an airstrike that happens. So I took that data and I combined it, merged it using those same data skills with Air Wars data, which is freely available, and another data set on airstrikes in Iraq, Jane's intelligence, and ACLED, armed conflict data. Being able to merge that it's very easy to do with pandas. Python pandas is quite easy to do that.
Yeah, pandas data
pandas package in Python, just merging all that data, the whole extract, transform, load, data transformation stuff, like that stuff. If you had to do manually through Excel, it'll take you weeks. This took me just a few days to do, and it gave us a really nice analysis, which we then a few other newspaper publications referenced us for that paper itself. And that's like just something very practical I did in my spare time, using some skills that weren't particularly special. Like a lot of people can do what I did for that.
Yeah, but you dedicated yourself like to just do these things.
Yeah, I just applied the skills I had. Python, pandas, learning how to scrape data, and combining different data sets.
لكم بروجكت كوتت مثلا عندك كاكتور بس ويدك كاتك دكتوراه تعاقد بالضبط صار دكتوراه تعاقد دكتوراه غير.
Yeah, about a year ago. Yeah.
صار لك بروجكت دكتوراه تعاقد.
Yeah, like February 2021.
پاژێکە دکتۆرای تاواکردێ لەبەر کاتی کۆرۆنا بوو بەتایبەتی لە بریتانیا وڵات هەمووی لە لۆکداون بوو فکر کردیتەوە چی بکەم هەستا دەست لایتە کۆدینگ بەتایبەتی لە پایتن و دیتا ڤیژوەلایزیشن و ئەو شتانە چی کردێ یارمەتی هەندێک لەو ڕێکخراوە خێرخوازیانە و یاخود سەر بەخۆیانەیدایە مەسەلەن کە ئیشیان کردێ لەسەر مەسەلەن ئەو کێشە و گرفتانەی لە عەفرین و لەو مەنتقانەدا هەیە دەیتایەکتان بەکاردێنە لەوەی عەفرین مەسەلەن دەیتایەکە چ بوو کە تو ڤیژوەلایز
data on reported kidnappings, murders, things like that.
مەسەلەن ئەو دەیتایانەی کە کۆکرا بووە لەسەر ئەوەی مەسەلەن ڕەفاندن و kidnapping و چی دکتۆر
kidnappings, murders, things like that, yeah, from the militias that came in there with Turkey.
مثلا ئەو کوشت و کوشتاری بۆ نمونە لە عەفرین و ڕفاندن و ئەو شتانێک کە لە عەفرین لەلایەن ئەو میلیشیانەی سەر بە تورکیا بۆ نمونە هاتوون لەو مەنتیقەیە یاخود هەر کەسێک کە کردبیتی ئەو دێتایان کە کۆ کردیتەوە دکتۆر یارمەتی داینە کە بە شێوەیەکی زانستی ڕێک مثلەن ئەو دێتایە مثلەن ڤیژۆڵایز بکرێ و پیشان بدرێ یارمەتی داینە ئەوەش بە هەندێک لەو پایتن سکیلانەی کە مثلەن خوێندیتەوە لەو کاتانێک کە فری بۆ لە مثلەن لە ماڵەوە بۆ لە لۆکداون بووە باکەڵ ئەوەشدا کە مەسەرەن بە دوای ئیشداگەڕایە مەسەرەتی بۆ دانیشتمەتەوەها ئەوەی کردی ئەوە وای کردیە کە لە دیپارتمنتێکی ئەمریکا و مەسەرەن ریسێرچە پەیوەندی پێ بکە
State Department's Bureau of Conflict and Stabilization.
مەسەرەن یەکێک لە بەشەکانی مەسەرەن یەکێک لە دیپارتمنتەکان یاخود فەرمانگەکانی حکوومەتی ئەمریکی گەروا بڵێم ئەوەی کە دەربارەی مەسەرەن کە لەسەر مەسەرەن ئەو منتیقەی خۆمان خۆرهەڵاتی ناوەڕاست و تورکیا ئەوانە مەسەرەن ئیشیان کردیە لەوێش پەیوەندی پێوە کردی یەک لە توێژەرەکان و یارمەتیدایە بە هەمان شێو بۆ ئەوەی کاتێک کە فۆکەی تورکی بۆ نمونە بۆمبابارانی منتیقە چی دەکا لە تویتەر مەسەرەن ئەوانەی کە تورکن هەتا چەند مەسەرەن باسی ئەوانە دەکەن ئەو دێتای لە تویتەر مەسەرەن ئەکستراکتکەی و بە پایتن ئەنەلایزیکەی و پیشانی بدەیت لەندرێ مەسەرەن یارمەتی ئەو جۆرە ئاکتیڤیتیانیدایە کەەوەش بەڕاستی پێدەت خۆشیە پیشانی پێدا کە تۆ لە ماڵەوە دانیشی تۆ داگەڵی بێ ئیشم یا دەگەڕێ بە دوای ئیشتا لەگەڵ ئەوەشدا کە مەسەرەن تۆ ئەپلای هەندێک ئیش دەکەی بەتایبەتی بۆ کوردانەی کە لە ئەوروپا و لە ئەمریکان حتا لە بۆ کوردستانیش دەکرێت لە پرۆژێکتی ئەوها بەشدار بکەی هەم سکیڵت باش دەبی وردەوردە چکۆلانەیە پرۆبلمێک بێتە پێشێک کە تو پرۆبلمی هەر ناکتە پێشێ لە داهاتوو لانی استفادەت بۆ سکیڵانە بکەی لە هەمان کاتیشدا دەناسرێ وەکو کەس مەسەرەن وەکو دکتۆر دوین مەسەرەن خەڵک پەیوەندی پێوە دەکا و ئەو پایتن پرۆگرامینگە نشی کە دیڤلۆپی کردیە بە تێکی یارمەتی دەرەوە دەست خۆش
Yeah, I mean, this is all like data analysis, data science. It's all about using data to support decisions and things like that. So visualizing data in a way you can make better decisions. And my work exactly with the American researcher or the effect of airstrikes and Yazidis was just being able to take the data, process and visualize it in a way where we could see, okay, 2/3 of every airstrike in Sinjar has affected Yazidi civilians in some way, like they've been injured or killed by it. So it's like stuff like this, where, for example, the American researcher I was working with wasn't like some people wouldn't be able to perform this kind of analysis visualization, especially like within certain time frames, like on a short time frame, which being able to learn Python or any other coding language would instantly give you the ability to do so.
متأكد دەست خۆش دکتۆر باسی ئەوەی دەکا ئەوانەی ئەو منەبیێت چوبی کە لەگەرە توێژەرەی یەک لە بەشەکان لە فەرمانگەکانی حکوومەتی ئەمریکا کە ئیشی کردێ مەسەلەن ئەنەلایزی ئەوەیان کردێ مەسەلەن و لە کۆتایەکەی مەسەلەن هەندێک لە شتانی کە لەیان دەرکەوت دوو لە سەرسی ئەو هێرشە ئاسمانیانی کە مەسەلەن ئەمریکا کردیتی ئەسڵەن زەرەری هەبووە لە بۆ خەڵکی یەزیدیەکەی کە لە سنجار و لەو مەنتیقەیدا هەیە لەبەرەوەی دوو لە سەرسەی هێرشە ئاسمانیەکان بوویتە سەبەبی ئەوەی کوشتن یاخود بریندارکردنی خەڵکی سڤیل لەو مەنتیقانە کە تۆ دەیتایە مەسەلەن کاتێکە ئەو هەموو دەیتایە دەینی بێک و پیشان دەدێ بە جۆرەك لە جۆرەکان هەر خۆی لە خۆیدا ئەو پیشاندان و ئەنەلایزکردنی ئەو دەیتایە کە هەندێک لەو حەقیقەتانت لە بۆ دەردەخا و بەڕاستی دوو لە سەرسەی هێرشە ئاسمانیەکانیش بێتە هۆی ئەوەی کە تو خەڵکی سڤیلی بێگوناح لەو مەنتیقەیە کە تو ئازار بچێژن بریندار بنیا بکوژرێن ئەسڵنەوە پێچەوانەی هەدەفەکەتە چکە ئەو هێرشە ئاسمانیانە بۆ چ بوو بۆی ئەو خەڵکە بپارێزی نەک بوو ئەوەی تۆ بێ مەسەلەن ئەسڵەن زەرەر بەوانە بکەین دەست خۆش دکتۆر دوای ئەوە مەسەلەن ئەگەر خەڵەنە لەو کۆمیونیکیشنانێک کە هەمان بوو باسی هەندێک لە سارێ کارەبایی و مەسەلەن باسی لەو پوینت و شتانت کرد کە لە ناو بریتانیا گەبمانوێت ئەگە باسی ئەوشم لە بۆ بکەیت ئەوە بەڕاستێکێک بلۆشتانێک کە زۆر بەلامەوە گرنگ بوو لەبەر چی لەبەرەوەی ئێستا ئەوەی کە دەبینین بە تایبەتی لە ئەوروپا و ئەمریکا بە شوێکی گشتی یعنی داهاتوو بۆ ئۆتۆمبیلی کارەباییە بۆ سیاری کارەبایی بەڕاستی و کۆمەڵێک کێشەمانێ بە تایبەتێکگە ئێستا فکر بکەینەوە کاکتۆرۆک و خۆت لەوانەیە لێرە بەوازحی هەستی پێ بکەی لە بریتانیا نرخی گاز نرخی بنزین بەرز بۆتەوە بۆ هی ئەو شەڕ و کێشەی کە لە مابینی ئۆکراینیا و رووسیا و شتانەدا هەیە طبعاً بینە پێش سای خۆت ئەگەر ئەمە مشکلەی ئەگەر ئەمە هەموو سیارەکانی بریتانیا بۆ نمونە کارەبایی بووە مەسەلەن ئایا کێشەیەمان دەبوونە بەڵام لە هەمان کاتدا ئێستا کەمە دێین باسی سیاری کارەبایی دەکەین یەک لە مشکلە ئەوەی کەم بیزانم یعنی ڕاستم کەوەگەر هەڵە بووم یەک لە مشکلە سەرەکیەکانمان چییە پێشەوەی باسی بێم باسی ڕیچارج چارجینگ پۆینتەکان بکەم هەست دەکەم مشکلەی سەرەکیمان ئەو پاتریە کارەبایانەیە کەمە لە سیارەکان هەمانە لەبەرەوەی مەسەلەن دەرێن 200 کیلومتر پێی دەڕۆی و نامینێ مەسەلەن دوایش کە دەتەوێت ڕیچارجیکەیەوە خۆکو ئەو نییە بنزینی تەکەی 5 دقه و چارج بیتەوە ئەگەر تۆزێک باسی ئەوم لۆ بکەی مەسەلەن لە ڕووی علمیەوە ئەگەر معلوماتت هەبی پرۆگرسمان لەکوێ لە ڕووی زانستیەوە لە بۆ ئەو سیاری کارەبایی
like so está o project like desprem cred că işçim dito negarian the data scientist negarian bum gotum está Britannia the government here they want to do this they put a report out they say they want something 1,000 charging points per 100 kilometers of road they have a goal by 2030 and we can do a project on this and we can sell it we can get grants it's a good okay so this was a very good case where you can use data to solve real world problems as a digital solution and this is something I think is very important in Kyrgyzstan itself this is something so yeah so the entire premise of this problem is you're going to have a lot of electric cars in the next coming years and you need the charging infrastructure to support that and the real thing is here you have this interface of companies which build and put down charging points they want to know where the best places are to put them you have the government which wants to know the utilization of charging points and the optimization of their charging point infrastructure to make sure it's efficient and you also have for example national grid the power electricity generation they want to be able to do forecasting
forecasting يعني predict كان يعني بزانن
بزانن like how كهرباء تسند كاردين stuff like that and even for example all of these electric cars they're just batteries aren't they so we can like the UK will suddenly have like a huge battery like battery grid of all these electric vehicles where if we aren't using electricity the grid can use it we can sell the electricity back to the grid so you have all these like and this is part especially is very cool this vehicle to grid technology like people can sell the electricity in their cars back to the grid so national grid the electricity company want to know based on supply and demand what pricing they should set to sell electricity and buy electricity at any time
I see
so this entire problem now is okay so how can we commercialize a solution to this so one thing I've been looking at is getting for example I have road data I have demographic data I can pull those from the internet from the government database websites from OpenStreetMaps or Google Maps I can pull all kinds of data but then we have also the problem of how can we make sure it's secure and private and we've been working on
as in when you say secure and private what do you mean by security and privacy
so perhaps
security and privacy of where to put or what is your plan to put these
not
charging
just
points
where to put the charging points maybe the utilization of each charging point or for example even things like maybe we'd be tracking things like the registration number of an electric vehicle that visits a certain charging point and where they go where they travel things like that so all this kind of data we'd want to make sure it's secure and private and we've been using a solution that uses federated learning where what we do is we send so we never take the data from anywhere so all our clients everyone keeps their own data we send our algorithm for a neural network to learn from their data and come back and we do that and then we aggregate that model so the only thing we see is the model coming back we don't actually see their data
I see so that you're not violating the privacy of the data
exactly and this is something I think that should be very important in Kyrgyzstan as well as we're becoming more and more digital these are data privacy and security I think something that's going to become very big in the Middle East and there's an opportunity there for youth absolutely to get into that
so sorry go ahead
so this project like really what we're doing right now is predicting where people will travel to where charging points will be most utilized based on both current data client data of current charging points usage And that could be due to a number of different factors. And we need to make sure there's no route that's regularly used that's more than 100 kilometers. That's 100 kilometers and doesn't have a charging point on that route. And you need to make sure there's enough charging points based on traffic data. Because my company has a separate team that currently runs the UK traffic data, traffic information service. So they've given me some of their data for me to also use in building our model to predict like charging point usage in certain areas and use that in a solution to optimize UK charging point infrastructure.
Yeah. And what okay مثلا أو somebody gets قبل درباري أو كارتورة سايش تكاد لسر أو يبون من الدهات وكاتك أما زوري سعر كان لبريطانيا بون مدبنا سعر كهربائي اما چون پیشبینی أو بكين لشو باشترين شو أنا كان شو نبو أو أما بابين شحني أو سعر كهربائي أنا دابنين يعني بوينتي ياخذ شويني شحن كردنا ويان دابنين مثلا لو شتاني كهي مثلا بجوري ستانداردي كهي دري همو 100 كيلومترك تو بيسته 1000 تشارجينج بوينت هبي بو نمونه لام بساره كوي شوي دابني مثلا مثلا زاده شي مثلا يكلا زاده شي مثلا قرب على وكو M1 ياخذ M6 ياخذ M25 نازان MC او انا كذا ريت عندنا دابني وشيكي قشتيش ناكريتو زاده هبي مثلا كتورش قرب على خنيه تشارجينج بوينت اللي نبي بینە پێش سای خۆت بۆ نمونەوە کۆ بەنزیخانانە ئێستا هەن و پەترۆل ستیشنانێک ئێستا هەن هیچ دەکات لەسەر ئەوەی ئۆپتیمایزی ئەوەی بکات مەسەلەن لە شوێن دەرەدا بنرێ یەکێکە لە ئیشەکان مەسەلەن ئەوەیە کاتێککە تۆ دەی ئەو چارجینگ پوینتانە دادنەی دەیتایان چۆن لێوەردەگری مەسەلەن لەوانەیە مەسەلەن لە ڕووی پرایڤەسیەوە پێویست بکات لە هەندێک شوێن مەسەلەن ئەگە سیارێک دێ شەحن دەکاتەوە مەسەلەن ئەتۆ بزانانی ئەو سیارەیە نەمبەر پلەیتەکەی چەندە مەسەلەن وانيا مثلا دەستەچێ مثلا لەو پوینتی چارجی کردیە دوای 100 کیلومتر دەوا لە پوینتێکش مثلا چارجی کردیە تۆ دەزانی ئەو سیارەیە لە پوینتی ئەی لە بۆ پوینتی بیلێن دەرە چارج
بۆ real time processing so edge computing يعني ئەگەر سیارەی زۆر بە یەک دڕۆنە ئەو جیانە دەتوانین بە real time بەرێن ئێستا دەماندی ئێرە زۆرە
بەتەکید ئەوە Kartur, I wanted to ask you a question about the battery itself. You know, one of the عبورن باشكي تريش لو شتاني كباسي كنت مثلا اما باور جريد معناه مثلا سنتري داواش كردن و دروس كردني وزي كهربائي بو همو بريطانيا ويك نسرا باور جريد ونيا مثلا لمن درش بينا كش ساي خود باش د 15 سالك اما اگر باشه چی زوری اتومبیل کان ایره دبن ساری كهربائي تو انا همو باترين هر همو شي تدا باتري كهربائي تدا مثلا حكومة دير لو دكاتة ولا همان كادا كم كهربائي بفروشي هم كهرباش بكري مثلا تو سعرش كهربائي مثلا بكاري نايني كهربائي ده مثلا وهذا تيو كهربائي كي بفروشي مثلا بحكومة او شارجينج بوينت بس الكهربائي اللي هو بيعطاني كهرباش بفروشي مثلا من دليل كم دقي حكومة مثلا او كومبانيا حكومة سافكر لو دكاتة سعري او كهرباء اشتري بك مثلا بتن كهرباء بفروشي بتن كهرباء بكري لهمان كادا مثلا كومالك بابتي تر اتوار دوريو that's for sure. I wanted to ask you a question regarding the battery, the charging battery itself. You know, one of the issues that we have in the current electric cars is the battery itself, because I mean, can we have a battery like charging once and it goes like 1,000 kilometers? I think the answer is no. I mean,
not at the moment. No,
it
will take a while. At the moment, battery technology is still improving in terms of energy density. It will take a while. I mean, I'm not up to date at the moment on where battery technology is, but we're not there yet. At the moment, I'd say around 200 is
around 200 is the maximum, right?
Yeah.
Do you think the bottleneck
around 100?
Do you think the bottleneck is how long is it take you from point A to B, or the bottleneck is the charging duration? For example, I'm running out of electricity in my car, and then the charging, is it 5 minutes, is it 10 minutes, is it 25, is it an hour?
Depends on how much you charge. For a full tank in a rapid charging point, probably about 30 minutes to charge the full, 45 minutes. But those are like the high-end rapid charging points. For standard charging point, it will take you a couple of hours.
And I'm assuming the half an hour, 45 minutes will charge you more.
Yeah, it's charging much faster. Yeah, And so like the idea is for most people, they'll be commuting to work. At work, we can have charging point grids that are hooked up to the office building, which can power these cars and go back. People will have charging points installed at their homes connected to the electric grid. So the main idea is based on the fact that people can charge at work and at home, you need to have charging points on routes for people who are commuting longer distances and things like that.
مثلا پێویستە هەموو ئۆفیسەکان چارجینگ پۆینتی لەوی لۆی هەر کاتێککە هاتی سیارەکان ڕاگرت ئەو کاتێک کە تۆ ئیش دەکەی لە ئیشتاو دەبی مەسەلەن سیارەکەت و شەحن بووە و یەک ماڵەکان لە مۆ زۆری خانە تازانی کە دروست دەکرێن و ئەوانی ئێساش کە هەن بەڕاستی وای لێ دەکات تۆ هەمووی پێویستی بە چارجینگ پۆینتە بیت ئەگەر تو سیارەکەت کارەبای و ناکرێتەوە مەسەلەن هەموو ڕۆژناڕۆژێک بڕۆی ساعتێک ساعت و نیوە یا 2 ساعت لە محەتێ ڕابستە سیارەکەت پول کارەبا دەکەی باسی ئەوش دەکات کە ئێستا مەسەلەن سیارێک کارەبای بە دوو نوع دەکرێت شەحن بکرێتەوە هیانە ئەوەی کە نۆرمەلی شەحن دەکات و لەوانەیە ساعت و نی 2 ساعتی پێ بچی لە هەندێک جێشت هەیە مەسەلەن چارجینگ پۆینتەکان مەسەلەن وزام تەکنۆلۆژیەکە باشترە ڕاپێ دەڵێن ڕاپێت چارجینگ پۆینت کە لەوانەیە نیو ساعت 5 دقیقە پۆلی مەسەلەن سیارەکەت چارج بکاتەوە کە دەتوانێت 150-200 کیلۆمەتر پێ بڕێ تەواو بۆ دنیا زۆر چاکە دکتۆر بەڕاستی ئەوانە یعنی شتی زۆر هیوا بەخشن باسی ئەوەشی کرد دکتۆر مەسەلەن وەزم گوتت نیورال نێت و
ئەوەی کاردێن بۆەوە for this because like mostly also because of privacy you don't actually see the neural network is pretty good for privacy but also for deep learning if you're taking in lots of data and in a federated data setting because we're using PyTorch here for this neural network in a federated data setting running on
can you explain to me what do you exactly mean by federated sort of modeling?
So in federated data what you're doing it's like an ensemble of where you take a machine learning model, you run it on this data set and then this data set and this data set separately, like in parallel, and then you can aggregate the results.
As in aggregating the weights or the scores of the final model. Is that how it works?
I'll give you no, I don't have an example on this computer. So for example, if I ran this model on a city like Birmingham, pick where to put potential charging points, and then I ran it on London, and I aggregated the model. So I had a separate model for London and Birmingham, and then I aggregated it. And then I'll be able to use that model to predict for Barcelona. Take the different city.
بس يكشف دبليرتي بقى مثلا كدري you aggregating the model. Let's say you have two convolutional neural networks. You're trained on Birmingham and London. So what is a trained convolutional neural network? It constitutes a set of trained weights. Now, how model when you say we aggregating it, you just aggregate the weights and you get another model whereby the weights are the addition of the weights or somehow the weighted sum of these two weights that you have from both cities. And you use that model to predict, for example, Barcelona. Is that how it works? It should, I think.
Yeah. So there's a couple of different reasons why we do it in this way. So the first reason is mainly because on current hardware I'm using just to train the models, it's a lot easier to do the entire processing steps for smaller regions and then combine them all together at the end instead of running on one big region. And this other thing is I can do it in parallel, so it's much quicker. And the third thing is obviously in terms of data privacy security, it also simulates how if we have different clients in different areas with different data sets, we can train the model on their end, come back with the model weightings, aggregate. We never actually see the data. For the moment, the project's in proof of concept stage, but like this is our approach.
This is your approach. Okay, دكتور باسي ودك ك privacy أو data كلا customer ودت green قبلانه شكون أكتو كومبانيا شيء مثلا كارتي تايبتي data مليونان خلق درباري أوتومبيل وبونمونا تنشح عندك ولا شو دروا ولا تبوينت شو تشارك شو بيت بولات فتذاك أو ماشين ليرنينج موديل عني كهيا بتاعتي convolutional neural network ياخد deep learning كهانا أو موديل عني خوان الجوريثم كان دنيرن لبو أو شو يعني كديتا كده أو ديتا كاستمي كده لبي ماشين ليرنينج موديل كان train كده كان باشا هینەوە بۆی لە شارێکی وەکو بۆی منە لەندەن دابش دەکەنە سەرچەند ڕیژنێکی بچوک مۆدێڵەکان دەنێرن مۆدێڵەکان لەوێن دەرێت تراین دەبن لەسەر ئەو دەیتایەکە هەیە کاتێک کە مۆدێڵەکان دێتەوە ئەگریگەیتی هەموو مۆدێڵانە دەکات یەک مۆدێڵیکەی گەورەی لێ دروست دەکا کە بڵێم گەورە نا هەر مۆدێلێکی دیکە کە وەیتەکانی وەیتی ناو ئەو کۆنڤۆلیوشنەل نیورۆ نێتوۆرکانی کە هەیەە بریتە لە وەیتی هەموو ئەو سەب convolutional neural networkانی کە ترینینگی پێکردی ئەوەش بۆ پاراستنی پرایڤەسی ئەو دەیتایی کە هەیە تصور کەم ئەو پرایڤەسیش يعني this must be a condition from the government in the future. That's why you're trying to have something to abide by the
not
rules.
Just because the approach or system we're taking this is also directly combined with at our Invention Research Center I work at in my company. We're using this kind of data factory, which incorporates things like federated learning, which we can deploy to other situations. So like I'm using it here for electric vehicles as a proof of concept. We're also going to use it in terms of anti-money laundering. If you have these models, you run it at this bank, this bank, this bank, this bank, you don't see their data, but you come back in terms of anti-money laundering and you'll have a better model for predicting, for example, fraudulent transactions.
Yeah.
Right. So it's things like this. It just makes it getting around, for example, GDPR, things like that, easier. It's better in terms of ethics and data privacy.
Exactly. And if I may ask you, so these sort of data that you use in your sort of models, are they available freely for anyone to?
So the majority of data I've used for the proof of concept is available freely. And then, for example, client usage, this is some charging points. This is stuff that will depend on the government and the client itself, which may be private, or in terms of or where people are going or traveling, when they link up with a charging point, stuff like that is private.
So, but I know some of the things maybe you cannot say or reveal because this may be the secret source of your company, but these sort of charging points in the future, who is owning them? Is it the government that owns these sort of charging points, or there would be private sector sort of companies?
Private sector. So like, for example, here we have private sector, you have SSE, you have a bunch of different companies who produce charging points and like put them down.
I see. So what is the role of government here then?
So for government, it's in terms of infrastructure. For them, it's important infrastructure and then forecasting, energy demand and supply for the power grid, things like that. For example, the UK has a roadmap of having a net zero carbon future in automotive vehicles and so on. So it's about reducing carbon footprint and things like that. And they want to move towards electric vehicles and have they like in the government strategy here in the UK, they said by 2030 we want to have world's best like charging infrastructure.
I see. And most of the data analytics that you're using in your company now is more or less is deep learning, nothing sort of classical.
Well, for example, in cases like this, especially in specialized, like I guess like for most people who in general use, they tend to use things like scikit-learn. So the issue of that is because a lot of different people have contributed to scikit-learn, it tends to not always work consistently, or some things are a bit different than what you expect compared to things like PyTorch, which is very well structured. So yeah, we use PyTorch, and in cases for what we're doing, which is with lots of data, and we just found the neural network to be like good for this solution.
Yeah, perfect. I hope that this is another motivation for more sort of young Kurdish scientists to go into data science.
Oh yeah,
learning,
I mean there's
learning.
so much. Yeah, there's so much different stuff, even in Kyrgyzstan itself. Like I know, like in terms of supply chain and agriculture, there's so much there just in forecasting and things like that, and supply and demand that you can do with good data. There's stuff in using blockchains to have like an audit log of what's going on in terms of data. Because I know the KRG, the government itself, I remember their Department of IT, their head of Department of IT, Kakiwa, he posted once on Twitter a video of them using facial recognition software and things like that. And I remember thinking, what's the data privacy like laws we have in Kyrgyzstan? What is the data privacy infrastructure? How are we doing that? And this is something that I think is quite an important topic. So how are we using AI ethically?
No, I completely agree. There are so many sort of opportunities for data scientists in terms of ethics, privacies, improving the state of the sort of algorithms that we are deploying, streets, maybe in Kyrgyzstan, especially in Erbil and Suleimani and Duhok. I think there are a lot of opportunities. Yeah, I mean, there are a lot of opportunities there. And to be honest, I don't know about any sort of ethics or privacy sort of laws that we have explicitly been passed in Parliament for these sort of issues. But I think that's a good thing. And of course, in order for a law like this to be passed, you need lawyers as well as data scientists and machine learning sort of specialists, computer scientists to be on board because somehow you need to know how these things works, even if it is in a very sort of high
so
level.
this comes down to like you go through university, you just study modules to pass exams, but then you have to do more than that. Actually, it's not just about passing exams, it's about what's going on in the current world and how can I apply what I've learned to solve a current problem.
Exactly. Very, very interesting. Well, I don't have any more questions in mind. I think we have came through your BScs and the time that you spent in United Arab Emirates all the way to your PhDs and the time in Swansea, and now working in a company where you focus on analyzing and predicting charging points in UK, which is, I think, is a fascinating sort of journey. So have you been to Kyrgyzstan and Koya before?
Yeah, I went in 2019 was the last time I went. I was supposed to go this year, but I couldn't get the time off work because I was discussing with like the rest of my family and so on. I was like, oh, when are we gonna go? And then we were not gonna go. And then my parents like called me and they said, okay, you know what? We're going 3 days from now. And I was like, oh, I can't book the time off now. But I miss Noros. And now like my friends over there and my family are telling me, oh, Noros next year is on Ramadan.
Yes, yeah.
I missed it. I missed out on it. Yeah, but no, I went back in 2019. How about you?
Yeah, I've been there like 2017. I think I didn't go back from that time.
Yeah, it's been a while. Yeah, I miss it. I miss it a lot. I have like from my grandfather, I have all his old books from his like old library in Koya, which is what I'm using to improve my Kurdish.
Oh, sorry, who is that? I cannot see the
Bedir Khan. So I have
Muhammad,
so many
Muhammad
old
Amin.
books. Yeah. Oh, can you see that?
Yeah.
Yeah, I have a lot. I have like an old shelf now. Like every time I go there, or I always ask my family, old books and things like that in Kurdish, like get it for me. Yeah,
Perfect.
I have a bunch. And it's like good because I can read Arabic script because of my time in the Emirat. So like for me, because I don't use Kurdish that much in daily life. لو من باشا حتى لبير هموي من بير ناتي نزاني هذوك عيب
لما رأي قصدك شو باب بكردي
لا بكردي خصان مكان بس يعني باسي ماشين ليرنينج و اي اي ناكم
بالتأكيد لانكستر شلون تشيلك تشيل اخوي وشلون يعني ايش
يعني it's like a demo كلية يعني ليش يعني دسمه هوليداي اونز يعني اخي من لخوم دجم لبو دسارة كده سبم كده الكلية بس لبو كورونا هات مو ماري
بري
انزا يعني بس باسي اوشتاني كان باسي باسي يعني اي اي يعني دكتور اتش كان يعني
بالتأكيد.
No, besides brother Jimmy is that's a doctor America away here. He has a media thing he's created, which is focused on Kurdish academic language to help Kurdish academics. He's Kurdish in their academic studies and so on. I think it's called Zanist Hoja. Zanist Hojan. Something like that. Okay. Yeah, so it's like stuff like this. I'm trying to improve it so I can do all my academic stuff in Kurdish as well. And like you, help people back home.
Yeah, sure. No, I'll try our best. As I said, I don't have any more questions. Thank you very much for the time you allocated for us. I think
No, thank you very
passed it.
much for the opportunity to share.
Yeah, thank you very much, and I hope that you share your other achievements in the future so that we can have like another meetings with you. It doesn't necessarily to be talking about your BScs and masters this time, but whenever there's something that you felt that okay, you need to share with the rest of the Kurdish youths and scientists, please feel free to let us know. برای زور سپاس بۆ دکتۆر دوین بەڕاستیم چێشم وەرگرت هەمیشە شتی تازە لێکێکی دیکەەوە فێر دەبیت کەمە لە مەتریال ساینسەوە هاتن دەستمان پێکرد هەتاوەکو ساری کارەبایی لە چەندەرێ و چارجینگ پۆینت و شتانەدا بنێن بەڕاستی جێرنێکی خۆش بوو هیوادارم سوتان وەرگرتبی زۆر سپاس ئینشاڵڵا لە پۆدکاستێکی تر و لە گفتوگویەکی تری زانستی تر زۆر سپاس دکتۆر
سپاس کاکە باشە
زۆر سپاس